December 2025. High above the ocean, the United States Air Force F-35 Lightning II locks on to its designated target, a fighter jet streaking through the combat zone at over 500 miles per hour. The F-35's pilot squeezes the trigger. An AIM-120 AMRAAM missile leaps from the rails and hurtles toward its target. Then comes the impact. The jet shudders. Instruments fail. Within seconds, the fighter explodes in a massive fireball and plunges into the waters below. Yet this was no foreign threat. The aircraft the F-35 just shot out of the sky was an American Lockheed Martin F-16 fighting Falcon. Why is the U.S. Air Force shooting down its own fighters? The truth is, this was no ordinary F-16. It was already dead. Deep in the Arizona desert sits Davis-Monthan Air Force Base, home to what's known as the Boneyard. It's a military aviation cemetery, the largest aircraft storage facility in the world. Row upon row of retired warplanes baking under the relentless sun, their combat day is long over. F-4 Phantoms from Vietnam, B-52 bombers from the Cold War, and hundreds of F-16 fighting Falcons that once defended American airspace. But some of these jets come back from the grave. Starting in the early 2010s, the Air Force began pulling select F-16s from storage and shipping them to the Boeing facility at Cecil Field, Florida. There, in a process that could cost anywhere between $1 and $2 million each time, teams of engineers would perform a bizarre resurrection, ripping out their old systems and navigation equipment and installing new ones. Though they're officially known as QF-16s, most call them by another name, Zombie Vipers, and their purpose is as dark as their nickname. These aircraft exist to be destroyed. They're full-scale aerial targets, the most realistic and capable target drones ever created. The reason for their existence lies in an obscure legal requirement. Title 10, Section 2366 of the U.S. Code. Any missile system must undergo live lethality testing against full-scale aerial targets before it can enter mass production. Not simulations, not subscale drones, actual fighter-sized aircraft. The Air Force previously used converted QF-4 Phantoms from the Vietnam era, but by the early 2010s, they were falling apart. When the last QF-4 was retired in 2016, the Air Force needed a replacement. The answer was the F-16. Of course, these jets fly with empty cockpits. They're controlled entirely by remote pilots on the ground. Yet unlike the subsonic, predictable target drones of previous generations, the QF-16 retains every lethal capability of its manned counterpart. It can fly at Mach 2, pull 9 Gs, perform complex combat maneuvers, deploy electronic countermeasures, carry threat replication pods that simulate Russian and Chinese fighter radars. To a missile seeker head, an enemy radar, or a pilot's targeting system, the QF-16 looks, acts, and fights exactly like a hostile Su-35 or J-11. Every year, roughly 20 of these zombie Vipers are earmarked for live-fire weapons testing. Real missiles, real warheads. Pilots from operational squadrons take their shots, validating the weapons they might use in actual combat. Yet only about 6 per year are actually destroyed. The rest survive. A proximity fuse detonates nearby, or a test missile with no warhead scores a hit, and the QF-16 keeps flying. It executes an automatic recovery sequence, glides back to base, and lands itself on the runway, ready to die another day. But flying a supersonic fighter jet from the ground, with no physical connection to the aircraft, no feeling for the machine, is both a technical challenge and immensely nerve-wracking. Preparation for a live-fire mission begins hours before takeoff. The QF-16, designated for destruction, is towed out to a special area called the droneway. Maintenance crews swarm over it, making final checks. Then they install something chilling, a warhead from an AIM-9 Sidewinder missile, placed where the oxygen bottle normally sits. This is the self-destruct mechanism, insurance that if the aircraft becomes uncontrollable, it won't crash into populated areas or ships at sea. About 45 minutes before launch, a maintainer climbs into the cockpit and starts the jet. They run through system checks, confirming that what the remote pilot sees on his control room screens matches what's actually happening in the aircraft. Then they climb out, close the canopy, and walk away. Inside the control room, the remote pilot, identified by the call sign X-ray, calibrates the Gulf Range drone control system. His hands move across the console. The co-pilot, call sign Yankee, sits beside him, monitoring the instruments. There's no video feed from the aircraft, no view of the sky ahead, just a bank of computer screens displaying a facsimile of the F-16's heads-up display, along with airspeed, altitude, and heading indicators. The chase QF-16, this one with a pilot on board, takes off first. It circles back and confirms that the ocean at the end of the runway is clear of boats. The remote pilot receives the 1-minute call. He advances the throttle, checks the instruments. Everything looks normal. The chase pilot radios through the instruction to roll the drone. X-ray releases the brakes and pushes the throttle to full military power. The F-16 begins accelerating down the runway, with no human hand on the stick. The chase pilot confirms it's tracking straight. X-ray hits the auto takeoff button. The jet accelerates under its own control, rotating at the perfect speed, gear retracting automatically as it climbs through the humid Florida air. At 1,000 feet, the remote pilot cancels the automatic mode and takes manual control. Now he's flying a supersonic fighter jet, using only instruments and a computer interface. No G-forces pressing him into the seat, no engine roar, no tactile feedback from the control surfaces. He can't feel whether the jet's about to stall or if he's pulling too many G's in a turn. He sets the autopilot to maintain airspeed and altitude, because without the physical sensations of flight, it's terrifyingly easy to make fatal mistakes. Meanwhile, an E-9A widget surveillance aircraft has been establishing the chute track, the corridor where live fire testing will take place, cleared of all civilian traffic. The QF-16 enters the track. Somewhere out there, another fighter is closing in, its missile seekers searching. Today, it's an F-35, and the mission will have a warhead. X-ray and Yankee watch their instruments and wait for impact. X-ray's hand hovers near the destruct button, the one that will detonate the Sidewinder warhead inside the jet he's flying. The AMRAAM hits. Instantly, the instruments go haywire. The aircraft still has power, it's still transmitting data, but the flight controls aren't responding. The remote pilot presses the auto-recovery button. Nothing happens. The jet is unflyable, and it's heading toward the open ocean with no way to control it. He presses the destruct button. The QF-16 explodes. Mission accomplished. But this was just one mission. The program behind these zombie Vipers has been running for over 15 years, and it just reached a major milestone. On December 4, 2025, Boeing delivered its 127th and final QF-16 to the United States Air Force, closing out one of the most unusual aircraft conversion programs in military history. The last aircraft carries serial number 831079. It's an F-16A, first entered service in 1984, spending 23 years with the 178th Fighter Squadron of the North Dakota Air National Guard, known as the Happy Hooligans. It flew countless missions defending American airspace, before being retired in 2007 and sent to the boneyard. Now, 18 years later, it's been resurrected one final time, reborn as a target, destined for destruction. However, the delivery of this final QF-16 signals a deeper problem. There are no more suitable F-16s left to convert. The Air Force has exhausted its supply of airframes that can be economically transformed into zombie Vipers. And even if there were more jets available, they couldn't meet the threats of tomorrow. China's J-20 Mighty Dragon and Russia's Su-57 Felon represent a new generation of stealth fighters that the QF-16 simply cannot replicate. These fifth-generation aircraft have radar signatures orders of magnitude smaller than the QF-16s. They maneuver differently. They employ fundamentally different tactics. The QF-16, for all its sophistication, remains a fourth-generation fighter pretending to be something more advanced. The Air Force knows this. Programs like 5GAT, fifth-generation aerial target, and NGAT, next-generation aerial target, are already searching for purpose-designed stealth drones to replace the zombie Vipers. But development takes time, and the QF-16 fleet must soldier on. The 82nd Aerial Target Squadron will continue flying its fleet of roughly 90 zombie Vipers through at least 2035, each aircraft living its strange half-life of 300 flight hours before meeting its end. Only then will the jets that refuse to stay dead finally be able to rest.